Now that you've had a chance to work this on your own, we're going to go over it. Tyler wants to buy some cherries at the farmer's market. He only has $10 and cherries cost $4 per pound. So let's talk about A. If C is the number of pounds of cherries that Tyler can buy, write one or more inequalities or equations describing C. So I'm going to start with how much money Tyler has. He has $10. If I'm spending money, I cannot go over the amount that I have. So $10 has to be greater than or equal to how much he's going to spend on the cherries, which is going to go on the right side of my inequality. If cherries are $4 per pound, I'm going to have to multiply 4 by the number of pounds that he buys. I know that C is the number of pounds that he buys. So I can simply put C next to 4, and that means multiplication. So 10 has to be greater than or equal to 4C. Let's go on to B. Can 2 be a value of C? To test this, I'm going to just take my 2, make your paper look like mine, and I'm going to plug it in to C. So let's test what that would look like. 10 is greater than or equal to 4 times 2, which looks like 10 is greater than or equal to 8. So I'm going to ask myself, is that true? Is 10 actually greater than or equal to 8? Yes, it is. So can 2 be a value of C? Yes. Let's test 3. Can 3 be a value of C? So this time I want to know, is 10 greater than or equal to 4 times 3? So that looks like 10 is greater than or equal to 12. Is that a true statement, class? No, it is not. So this inequality is actually not true. I'm going to circle it and draw a slash. So my answer to that question is no. Then it says, what about -1? Here's the thing with -1. I know that C is the number of pounds. Can I buy -1 pounds of something? No, that doesn't really make sense. So I cannot buy negative pounds of cherries. I can only buy positive amounts. C. If M is the amount of money in dollars Tyler can spend, write one or more inequalities or equations describing M. So I know here that my M has to be either less than or equal to 10, because he only has $10. So this is actually a much simpler inequality. Can 8 be a value of M? Is 8 less than or equal to 10? Yes. So my answer to my first question is yes. If he spent $8, how many pounds would that be? That would end up being 2 pounds of cherries. 4 times 2 equals 8. Can 2 be the value of M? 2 is less than or equal to 10. So far that's looking okay. But let's see how many pounds of cherries that would be. Because each pound of cherries is $4, I know that half a pound of cherries would end up being $2, because 4 times 1/2, or 4 divided by 2, equals 2. Could he just buy half a pound of cherries? Sure. So my answer to this question is also yes. What about 10.5? So let's test 10.5. Is 10.5 less than or equal to 10? No. 10.5 is greater than 10. So the answer to my third question has to be no, because Tyler does not have 10.50. He only has $10. We're going to move on to lesson 7. This is looking at data as well, except instead of dot plots, we're going to look at histograms or bar graphs in this lesson. So this is a new type of data distribution that you have not seen. So I'm really going to do the first problem completely with you, and then you'll try number 2 on your own. So it says these 2 histograms show the number of text messages sent in 1 week by 2 groups of 100 students. The first histogram summarizes data from 6th grade students. The second histogram summarizes data from 7th grade students. Okay, so I'm going to pause and just think for a second about what's going on. In this problem, 6th grade students, 100 of them, were asked how many text messages do they send in a week? And then 100 7th grade students were asked the exact same question. So all the numbers that I'm seeing down here on my x-axis, that's the number of text messages. On my y-axis here, that's the number of students. Since that's not labeled for us, let's go ahead and just label it here. Number of students who sends that amount of text messages. So the higher the bar, the more students send that particular amount of text messages. A says this: do the 2 data sets have approximately the same center? We've talked about this word. This means when I rate or rank all of my responses from lowest to highest, what is my middle data point? So it's exactly the same as a median or middle point. If so, explain where the center is located. If not, which one has the greater center? So the first thing I'm going to think to myself is, if it's 100 students, what's this middle number of 100? What is the center of 100? So I know I'm looking for about the 50th response here. I can be inexact. I can estimate a little bit because my question says approximately. So for each of these bars, the first thing that I'm going to do is I'm going to write above it the number of students at that level, because that will allow me to count up to the 50th response. So this bar looks about between 0 and 5. So above it, I'm going to write 3. My next bar is between 10 and 15. So above it, I'm going to write 12. My next bar looks just higher than 20, but certainly not at 25. So I'm going to guess this is about 21. My next bar is above 25, pretty far above it. So this one could be, let's say, 28. Then I'm back to about 20. I'm back to just above 12, so we'll call this 13. These are the same. Okay, it's just under 5, so let's say each one of those is 4 and 4. And then this is my lowest bar. This could either be 1 or 2, I'm not really sure. So now what I want to do is I want to say, okay, when I count up to 50, how many text messages is that? So 3 plus 12 is 15, plus 21 is 36, plus 28 is going to get me above 50. So I know my 50th response is going to be right here in my middle bar, which is between 85 and 95. So my center for 6th grade students is 85 to 95 texts per week. Go ahead and add your unit. Okay, since I labeled all of the 6th grade bars, I'm going to go ahead and have you label the 7th grade bars, and then see if you can find the center or the median of those 7th grade responses. So you're looking for the 50th response. Go ahead and pause and do that now. All right, now that you've had a chance to try it, let's look up here and go over it. So this first bar is between 5 and 10. It's pretty close to 10, so I'm going to guess that's about 8 or 9. We'll write 8. This next bar is just above 30, so we'll say maybe 31, 32, 25, and then this one's about 5 or 4. So your numbers do not have to be exact, but hopefully they're somewhere near mine. And then I'm looking for my 50th response. 8 plus 30 is going to be 39. And then once I add 32, I know my 50th response is going to be right here in the center. So it's between 95 and 105. So for 7th grade, I'm going to say 95 to 105 texts per week is the center. So which one has the greatest center? Looking at these two, which one is greatest? 7th grade has the greatest center. B, which data set has a greater spread? Okay, the word spread means the same thing as range. So that's where I say the difference between the lowest to highest. So for this, what I need to do is I need to look at the lowest number compared to the highest number. So 6th grade goes from 45 to 155. So my 6th grade range is 155 minus 45. That's going to give me 90. Then let's look at 7th grade. 7th grade goes from 75 to 125. So 7th grade goes from 125 to 75. 125 minus 75 is giving me a range of 50. So which data set has the greatest spread? 6th grade has the greatest spread because their responses have a range of 90 texts per week. 7th grade responses are more concentrated with a range of 50 texts per week. This means that 7th graders text at about the same rate as each other, whereas some 6th graders text a lot more and some text a lot less. Some 6th graders text a lot more and some text a lot less. Overall, which group of students, 6th or 7th grade, sent more text messages? When I look at my concentrations here, okay, 75 to 125 versus, 45 to 155, I'm getting most of my responses in this range right here. We'll say between 75 and 105 for 6th grade. Whereas 7th grade, I'm getting most of my responses between 85 and 115. Which of those is greater? The 7th grade one is greater. So when it says which group sent more text messages, 7th grade sent more text messages than 6th grade. Okay, number 2, I want you to actually try this one on your own. So you're going to pause the video, try number 2 totally on your own, look up when you're done. Okay, let's go over it. 46th grade students ran 1 mile. Here's a histogram that summarizes their times in minutes. The center of the distribution is approximately 10 minutes. On the blank axes, draw a second histogram that has a distribution of times for a different group of 46th grade students, a center at 10 minutes, less variability than the distribution shown in the first histogram. So less variability means that I'm going to have more in the same place, right? So fewer bars, maybe I'll just have a few different bars. And then the center needs to be 10 minutes. So I'm going to have 10 minutes be my highest bar here. Okay. So let's think about what that would look like. Maybe instead of starting from 4 to 6,